Okay, so what we're going to do is we're going to take a day 2 for this 6.1 that we started yesterday. All right, and we skipped over this part yesterday on how to do this with your calculator. I'm going to go ahead and just tell you, you're not going to be able to use your calculator on quizzes or tests when we're doing this. This is purely something just for your information and also just so that if you want to check your work, you can. You don't have to know how to do this, and you won't get to do it on a quiz or a test. All right, but it is kind of cool. So when we're looking at something and we want to graph a slope field, and we could have picked any problem, but let's just pick this one because it's on your paper. We learned yesterday anyway, how to do this by hand. Okay, you just make a triple T chart, you kind of go through and you find the slopes and you put the little segments on. So your calculator will do this as well. I want you to hit the mode key if you have your calculator, and if not, just look up here. So right now this is in function mode, okay? And that's what you want pretty much all of the time, all right? If I hit the right button though, it gives me different options. And all the way down here for diff equations, that stands for differential equations. If you want to graph a slope field, this is what you need to select. All right, and then you got to press enter again to save it. Okay, at this point, if I do diamond F1, that's how you go to y equals, and I actually already have this typed in from my previous class. But let me just clear it out, just make sure that we all got it. So dy over dx, another way to, well, that's just going to keep happening. That's okay. Dy over dx. Another way to write that would be to write y prime, right? So in your calculator, it's going to be y1 prime. Now, this is something that's kind of weird, but instead of x, your calculator is going to use t, and y, again, is going to be y1, okay? It's written right here. So that's what you got to use t for x. That's what most students forget. So we're going to do t minus, and t is just x, y, z, and then t. So t minus y 1, and if I press enter, make sure yours looks like this, and it's in your notes right here in case you don't have your calculator today. All right, and now if you hit diamond F3, it's going to graph the slope field, and it's kind of cool. It's going to just do all the little segments for you. Okay, this is going to be a way you can check your work, not something you have to do. All right, so yesterday we did the little wiki sticks activity, and you guys, this is all the little wiki sticks. But do you remember how you had the long one that was a different color, and you had to put that one on? That was the solution curve, okay? And in order to do a solution curve, you have to have an initial condition. One way this initial condition could be written as a point. It could be written as function notation. But either way, basically our initial condition would be yi1. That's how your calculator, that's the notation your calculator is going to use. So we're going to go back to y equals, which would be diamond F1. And underneath it, you can see it says yi1. I stands for initial. And we're going to type in -5. And then make sure you press enter so that it gets in. And what your calculator is going to do when we press graph, it's going to show the slope field again, and then it's going to show the graphing of the solution curve. So if I hit diamond F3, and everything I'm saying is written on your notes right here. Okay, so if you notice, it started at 0, -3, and it goes up this way, and then it's going to do the other part this way. So during the activity, I had told you, put the middle of your long wiki stick on the given point, and then make the rest of the curve follow the slope field. Okay, so this is how you do this with your calculator. It's just to check your work. All right, now if you're going to use your calculator for just like normal graphing, you can't do it in this mode. Remember, we changed the mode. So I want to make sure you understand how to change it back. You're going to go back to mode, and I'm going to encourage you to go ahead and do this now. And then that way it's in the regular mode, and then you can always change it to differential equations if you want to use this. So I can see that I'm in differential equations mode. So I'm going to go and press right. And do you remember what the default was, the one we want most of the time? Function. And there's a lot of other modes, but we won't talk about those today. Make sure you press enter to save. And so now this is just graphing something that I had in y equals. Okay? So make sure you understand how to go back and forth, but mostly just make sure that you're not standing in differential equations mode when you're trying to do other stuff. So that's how you do this in your calculator. All right, yesterday we went through one example. We're going to do 2 more today. So I want you to turn the page, and this example right here is from the 2007 test, and it's a free response question. Now, you may or may not remember me saying this, but free response questions are worth 9 points. There's 6 of them on the whole test. 4 usually are like non-calculator, and 2 are calculator, and they're 9 points each. Okay, so they're broken up, and like part A is worth 2 points, and part B is 3, or whatever. It's different each problem. And do y'all remember what I said was good to shoot for?
5.
If you can consistently get 4 to 5 points, you are going, and you do decent on the multiple choice, you're going to get a 3. We're not shooting for perfection, okay? Because some of these are going to be really hard. Like part D on this problem is really difficult. It's not impossible, but it might not be something that you're able to get on your own. The slope-filled part, though, is easy points, okay? What I mean by easy points is all you got to do is your little triple T chart. Now, if you notice any patterns, that's great. That's going to save you time. If you don't notice any patterns, or there are no patterns, then that's fine too. So just start with any point that you want. Is that one of y'all's phones, or is that
No.
the iPad? Well, I can't get into that, so we're just going to have to deal with that. All right, -1, 0. Are y'all going to be okay? Y'all can move if the noise is bothering you. Okay, so -1, 0. I'm just going to start with that one. Now, I'm going to go through this part really fast because class is a little short today, and I want to make sure that I have time to explain the other stuff. All I'm doing is plugging in the x value in for x, plugging in the y value in for y, and crunching the numbers. I am just going to do it really fast. So 1/2 times -1 plus 0 minus 1 is -3/2. Okay, and I'm pretty good at crunching numbers, but mostly I've done this problem several times by now, already today, so I have a lot of this memorized. All right, so then I don't notice any patterns yet, so I'm going to go to -1, 1. This would be -1/2 plus 1 minus 1. Okay, that's -1/2. So again, negative, but this one should be flatter, not completely flat, but flatter. Don't get too caught up on how steep should it be, but you do need to know, is it increasing, is it decreasing, and how flat should it be. All right, -1, 2. That's going to be -1/2 plus 2 minus 1. Anybody know what that is real fast? 1/2, good. So that's positive, still pretty flat though, but at least positive. Okay, I want you to try to finish this one on your own. Okay, so this is what I got for the rest of my T-chart. Okay, so when we look at this, 0, 0, you should have gotten -1, which would be just the standard steepness. 0, 1 is 0. What type of line has a 0 slope? Horizontal. This is something you have to keep straight. You can't get the horizontal and the vertical mixed up, and that is easy to happen. Okay, 0, 2 is going to be 1, which is the standard steepness. 1, 0 is going to be -1/2. Again, kind of flat, but decreasing. 1, 1 is going to be +1/2, so kind of flat, but increasing. And then 1, 2 would be steeper and increasing. Okay, so on a problem like this, your slope filled would probably be worth 2 points. It might be worth 3 points. It really depends on the problem and what they decided, how they decided to grade it that year. It's not though like if you get half of it right, you get half of the points. It's typically if you make more than a couple of mistakes, you're not going to get the points. All right, but like I said, easy points to get. If you're like, this isn't easy, it's not easy today, it will be easy. Everybody is going to be good at this. You just have to practice it. Okay, now to do part B, it's going to get a little bit more challenging. So d squared y over dx squared. What is that telling us to do? The second derivative. So the second derivative is going to be the derivative of the first derivative. Okay, so remember I'm just going to kind of write it up here. It was 1/2 x plus y minus 1. That was the first derivative. So what is the derivative of 1/2 x? 1/2. What's the derivative of y? 1, but...
dy over dx?
Yeah, times dy over dx, and you don't need the 1, actually, but it's not wrong to put it. All right, and then the derivative of -1 would be nothing. So this is fine, except that it doesn't really follow the directions of in terms of x and y. So what you got to do here is you have your 1/2, and in place of dy over dx, you've got to write what dy over dx equals. Does everybody see where I got the rest of this problem? This is always the part where everybody's kind of zones out for a second. I just, in place of dy over dx, I put in what dy over dx was. So that's the second derivative. So that's another point right there that I got on this problem. Remember, we're shooting for 4 or 5 at least. We're going to keep trying to get all of them, but this is doable. Okay, now we got to describe the region in the xy plane in which the solution curves are concave up. We just found the second derivative. So what do you guys think?
I mean, if they're positive, then
Well, we could plug in, but there are actually infinitely many numbers I could plug in. Because we're not just talking about integers here. But positive was the right way to think here. Okay, what we want to do is we want to look at my second derivative. Hold on, I'm not going to write that. We want our second derivative to be positive, right? So here's how we can write our answer. All points such that, and then let's write our second derivative. And if you wanted to make that 1/2 plus 1 a -1/2, that's great. You didn't have to do that though. Okay, but that would have been okay. You guys see what I did? 1/2 minus 1, that's a -1/2. And then plus 1/2 x plus y. We want that to be positive. Okay, that's great. One thing you might see here sometimes, maybe on a multiple choice, or what especially like a college professor would say a better way to write this, is to get y by itself. You don't have to do that though, because then now it looks like an equation of a line. So all the points, you know how when you would graph a line and you would write a dotted and then you'd shade above or below? That's what we're talking about here. All the points in that shaded region, that satisfies the solution curves being concave up. But the whole idea here is we didn't really have to think that hard about it. We've got second derivative concave up, second derivative is positive, end of story. So don't think, I don't remember how to do that. Think, well, what do I know? All right, so let's look at part C. Part C says, well, let y equals f of x be the particular solution with an initial condition. All right, remember, this is just like the coordinates of a point. You can write that down if that helps you. Does f have a relative min, max, or neither at x equals 0? All right, so let's think about, normally we would do like a sign chart, but we've never done a sign chart with 2 variables. All right, so let's think based off of what we have. What should the first derivative equal at a max or min? What should the first derivative equal?
0.
Yeah, think about it like this. What's the derivative at either of those points? 0. Well, let's double check that. Remember, here's my derivative. I've kind of wrote it up here. So 1/2, in place of x, I'm going to put 0. In place of y, I'm going to put 1. And look at that. It equals 0. Everything's great. All right, so that tells me that I probably do have max or min. And again, we would normally do a sign chart from here. I'm not saying there's no way to make that happen, but we have never done that, and it's very difficult. We do know the second derivative. Look at my pictures down here. If you knew that the second derivative was either positive or negative, could you then figure out whether it was a max or a min? Yes, based off the concavity. So what we're going to do is now find the second derivative. All right, hang with me here, guys. So the second derivative, and again, you could use this form or you could use the other form. It doesn't really matter. All right, 0 plus 1 minus 1. That whole thing equals a half, which is positive. We're not going to do part D, by the way, so you can just scratch it out. And I'm going to write my answer here in blue. So what does F have? What do you guys think? How do you know that? We know that because dy over dx is 0. That had to happen. And we know that the second derivative is positive. Oh, it's not a max. Sorry, I'm just like, long day. Which one of these pictures fits a positive second derivative?
The right one.
The right one. That's okay. This is easy to mix up. This is why I like the picture, looking at the pictures. This is why it's good to write your justification. Mostly because you got to get the points, but it's easy to make this mistake. Remember, this was positive, which means concave up. You don't actually have to write that. This follows second derivative test, which means that if the first derivative is 0 and the second derivative is positive or negative, you can figure out whether you have a relative min or max. So tell me, what would have caused a relative max in this problem if the second derivative had been negative? All right, what if the second derivative was 0? Okay, remember, and here's the thing. I'm not asking you to remember a time when I said one specific thing. I think that's where a lot of students kind of go wrong. They're trying to remember everything I've taught you. Just think, what does the second derivative stand for? What does it tell us? Concavity. So if I said the second derivative was 0, what does that tell you about the concavity? It doesn't have any concavity. It's not concave up or concave down. But we know that when we have a max or min, we're going to have concave up or concave down.
So we would never have like both of them equal, like the first derivative.
Well, you would write neither if that was the case. Typically, that's not a question you're going to be asked. You're going to be asked a question that's more interesting than that, like where it actually does equal something. But you would say neither if that had happened. Okay. All right, turn the page. We're going to do one more problem.
Oh wow, thank God.
Okay, good. All right, so this was from the 2004 test. All right, and we're given another differential equation. The difference is this one does have easy patterns to recognize. Can any of you tell me, like, something you know, a whole row or column? Okay, I'm going to help you out here. What happens when x is 0? It doesn't even matter what y equals. What happens when x is 0? What does the whole thing equal?
0.
0. So when x is 0, the slope is 0. Okay, x is 0 at all 4 of these points. Make sure you put a horizontal line, not a vertical line. You can't get those mixed up. There's another thing similar to this, but it's for the y value.
And y is 2.
When y is 2, it doesn't even matter what x is. When y is 2, 2 minus 2 is 0. The whole thing's going to be 0. So that would be these 2 points. So we now have more than half the points just based off of that pattern. 0 is your friend. It's going to help you out on a lot of these problems. Not every single one. It didn't on the last one. But here we go. Okay. So let's just start at 1, 0. I've run out of patterns. I'm just going to start at 1, 0. Okay, so then 1, 0 would be 1 to the 4th times 0 minus 2. What does that equal?
-2.
-2. -2 is going to be a decreasing steep segment. All right, now, instead of just going up, I want to go over here. What happens when 1 is negative?
No, it's good.
When you take something to the 4th power,
That's gonna be
does it
positive.
matter whether it's 1 or negative 1? No. So everything over here on the left is going to copy, like everything for x equals negative 1 is going to copy exactly from when x is positive 1. So let's try 1, 1. 1, 1 is going to be 1 to the 4th times 1 minus 2. That's minus 1, which is just decreasing but like standard steepness. And that same thing is going to happen over there on the left. Because 1 to the 4th is the same as negative 1 to the 4th. If you don't recognize this, it's okay. You're just going to do a little bit of extra work to get there. All right, what about the last one? 1, 3. What's 1 to the 4th times 3 minus 1? 1, which is standard steepness increasing, and then this over here is going to do the exact same thing. And there we have a slope field. And we got 2 to 3 points depending on the problem. And if you practice this, you're going to get these points. When you take that AP test, if you see a slope field problem, you should be like, I got this. This is easy. Don't be too confident. Don't be arrogant. But
Do we have, like, do you have to draw, like, the shape that it makes?
not unless it says. So here it just said sketch a slope field at the points indicated. If it says and the solution curve through this point, then that's when you need to do it. And sometimes you are going to be asked to do that. I think on the homework one time you are.
What would that look like? Just like-
Well, we're not given a point. This one's not too obvious. Remember the ones that you did with the winky sticks? It was more obvious. That's the ones you're typically asked to do that in. Okay, so let's look at this one. It says, while the slope field in part A is drawn at only 12 points, it's defined at every point. Describe all the points for which the slopes are negative. What do you think about when you hear that phrase? Slope, negative. The derivative is negative. So I'm going to go ahead and write it because I thought it. Maybe that alone gets me a point. And now I'm going to write it out. All points such that, and then what was the derivative? It was x to the 4th times y minus 2 less than 0. Okay? That's our answer. Now, you can get more specific here. This one's even more obvious, I think, than the other one. If x to the 4th times x minus 2 is less than 0, okay? And some of you, nobody in here said this, but some of you might have been thinking, let's just list out the points where the slope was negative. But remember, we're talking about the entire slope field, not just the little portion that we did. Okay? What has to be true about x? X to the 4th is always positive, right? Except for one tiny little situation. When x is 0. So x cannot equal 0. If you're like, I never would have thought of that, that's okay. Remember, we're doing the best we can. It's doable to get 4 to 5 points. You might not get all 9 points. You're just going to get better at it, though.
You have to do the same thing for y.
You have to do the same thing for y. So what has to be true about y? It can equal 2, but even more specifically, it can't be greater than 2.
Lesson.
So a y has to be less than 2. We want it to be negative.
Oh, yeah.
We want it to be negative. All right, now this next part, I know I went through that pretty fast, but I wanted to make sure I had plenty of time to go over this last part. Because typically on these, this part is worth maybe like at least 4 points. It's usually a big, but there's a lot of easy ways to get points in the beginning. All right, so first of all, when it says find the particular solution, I want you to rewrite your derivative. This is really saying, hey, integrate, get the y equals. Okay, but I'm not ready to integrate yet. You guys remember what we have to do here?
With the dx over to the other side.
I have to move the dx over to the other side, but I also have to move this. Okay, look, this is x to the 4th times y minus 2. So how am I going to get rid of that y minus 2? I'm going to divide it, and this is what it's going to look like. We haven't seen this yet. It's going to look like that. 1 over y minus 2 equals, or dy equals x to the 4th times dx. Okay, we've separated our variables. So what are we ready to do now? We are ready to integrate. Now, do any of you know what the left side integration equals? Just like, you got it, no work shown. It is natural log of y minus 2. Very good. The rest of you are thinking, I couldn't do that in my head. So guess what? When you can't integrate in your head, what strategy should you use? What's that whole strategy we spent like weeks on? Use substitution, not guess in your head. All right, so we're going to let you, in this case, the only logical thing to do would be let u equal y minus 2. Then what would du equal? 1 times d, in this case y. But yeah, normally we would say dx. Okay, look at that. This is great because 1 dy is right there. So this whole thing turns into 1 over u du, which is natural log of u, which is natural log of y minus 2. All right, now here's the thing. The better you get at this, the less work you have to do. That's all I'm going to say. You do use substitution or don't, but you've got to get natural log of y minus 2. Okay, the right side is considerably easier. All right, on the right side, we need to add 1 to the power and put the reciprocal in front. And of course, we need our plus c. Okay, so here's the deal. You probably, usually the way these work out, you got a point just for separating your variables and showing that you needed to integrate. Like, just like right here, you already got 1 point out of this problem. Another point for integrating correctly. Maybe 1 point for each side, maybe 1 point total. It just depends on the problem. Okay, what we need to do now is get y by itself. Okay, so can any of you remind me, what does ln mean? What is it? Okay, everybody stay with me here because I don't want you to lose me. I don't want to lose you on this one. What is ln?
Natural
Log of base e. Okay, it's log log base e. How do you rewrite something from a log? Because I got to get y by itself. So how do you get, unhook or untrack that y? You're going to rewrite it as exponential. In other words, e to the power of the other side equals y minus 2. So I'm going to write it as y minus 2 equals e to this power. All right. Watch me on this next part. This is going to seem weird, and then a day or two from now, you're going to be totally fine with it, okay? C just stands for a number, right? It's just some constant. Okay? Watch what I'm going to do with this. Okay? Just be okay with this. Okay. E to the 1/5 x to the e to the 1/5 x to the 5th plus c. That's the same thing as saying e times e to the c. Right? What would x squared plus x to the 4th be? X to the 6, because you'd add the exponents. I'm kind of doing the opposite of that. All right, now e, that's a number, right? If you take a number to the power of another number, what do you get? You get another number. So I'm going to cross that off, and I'm going to write just c. The c in the exponent is not the same as this c. We could use subscripts here and go c sub 1 and c sub 2. You don't have to, but you can. Remember yesterday I used the term loosey-goosey with the c? You can't. C is just some number. It's not that it's already changed values here. That's okay. It's just some number. I can be loosey-goosey with it until I plug in my initial condition. Okay? So this whole right side turns into, I want you to write it this way because this is how you're going to be seeing it. And then if I just want y, what do I need to do with this 2? I need to add 2. Okay, I'm going to rewrite this. I'm going to go back up here, and I'm going to rewrite that here. Y equals c e to the 1/5 x squared plus 2. Okay, any questions? I'm not done yet. If I got to use my initial condition. If it's weird, it'll be less weird the next time you see it, and then eventually it'll just be like normal. We'll talk more about that tomorrow. All right, now I am ready to use my initial condition, 0, 0. We love 0. It makes things easier. So plug 0 in for y, plug 0 in for x. Why did I put a 2 there? That should be a 5. Sorry. Okay. What is this whole part? E to the power of what? 0. And what is the e to the power of 0? It's just a 1. So I end up getting 0 equals c plus 2. So what is c? -2. Okay. We were really loosey-goosey with c. That's fine. Now that I have said that c is -2, c is -2, and it will always be -2 in this problem. I can't just be wishy-washy with it anymore.
So you have to.
I do need to write my final answer. So y equals -2 e to the 1/5 x to the 5th plus 2. That's your final answer. Don't just stop with finding c. You do have to write your final answer. You have to put it all together. Okay? All right, your homework is the next 4 problems. Hopefully you got a start on that last night with at least some of the slope fields. If not, you have 4 problems. You will have questions on some of these. That's okay. You got to try it and then bring your questions.